Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Danial bin Muhammad ASRI. So today, I will be presenting my final year project that is Coir Fibre Reinforced Polymer Composite Simulation and Modeling of Mechanical Properties via Ansys. For the project outline, it consists of project summary, introduction and objective, problem statement, literature review, scope of work, methodology, and preliminary result. Project summary. Uses of natural fiber reinforced polymer in replacing the current synthetic fiber composite, that is glass FRP, based on sustainable development goals, which consists of universal call action to end the poverty, protect the planet, and uses a renewable source. The material used in this project is coir fiber composite that runs on Ansys APDL simulation software for tensile, bending, compression, and quasi-static tests with a few layup sequence. After get the results, the natural fiber was compared to synthetic fiber and made a hypothesis whether the fiber can be used or not in our current technology. Introduction. Composite, also known as a fiber reinforced polymer composite, are made from polymer matrix that is reinforced with an engineered, man-made or natural fiber such as glass, carbon, or aramide, or other reinforcing material. As you can see in the picture below, the matrix protects the fiber from environmental and external damage and transfer the load between the fibers. The fibers, on the other hand, provide strength and stiffness to reinforce the matrix and help it resist cracks and fractures. There are two types of fiber, which are natural and synthetic fiber. For example, wood. A natural fiber composite that is a combination of cellulose or wood fibers and a substance called lignin. The fibers give wood its strength, and lignin is the matrix that binds and stabilizes them. Plywood, on the other hand, is a man-made composite that combines natural and synthetic materials. Thin layers of wood veneer are bonded together with adhesive to form flat sheets of laminated wood that are stronger than natural wood. Next is objective. The first one is to evaluate the effect of fiber orientation on tensile, compression, flexural, and quasi-static tests on strength and deformation of coir fiber reinforced polymer composite. The second one is to determine the effect of layup sequence of coir FRP composite. And the last one is to assess the effect fiber orientation and layup sequence on stress contour of coir FRP composite, for example, the force direction. Next is problem statement. Natural fibers are well known as eco-friendly alternative to conventional fiber for composite reinforcement, but on the other hand have a lower strength than conventional fibers that has a significant level of moisture absorption, which are their major downsides. Complex characteristics of natural fiber make the experiment harder because the experiment can be done by a certain condition, for example unidirectional or multi-directional. The experiment can take a lot of time and cost, and because of that, I use Ansys APDL simulation software to determine its strength and deformation. Meantime, for determining the mechanical properties and dynamic characteristic of coir FRP composite is critical because composite have appropriate stiffness and damping coefficient can be used in a variety of applications that require characteristics such as strength, rigidity, lightweight, and environmental friendly. Coir FRP composite were utilized to construct seat cushions for Mercedes automobiles as an example of its application in industrial automotive. Despite their benefits, coir FRP composite have certain drawbacks, including dimensional instability, flammability, which makes them unsuitable for high temperature application, and degradability in the presence of humidity, UV lights, acids, and bases. Fiber orientation. The orientation and position of composite will affect the value of properties. A lamina is critical component of a composite consisting of an elementary layer of unidirectional fiber in matrix. Coir FRP composite has a variety of fiber orientation, for example unidirectional, multidirectional, and woven. Unidirectional laminates are dependable on the direction when loaded. For modeling and simulation, it uses finite element analysis FEA for modeling in this field of study. The second one is to analyze composite material, for example, type of matrix and fiber, their composition, manufacturing process, and uses using simulation techniques. FEA is becoming more common in the analysis of natural FRP composite, with Ansys being most widely used software. Scope of work. It consists of 4 testing types, which are tensile, compression, flexural, and quasi-static. The fiber used in this experiment are coir and glass fiber, which run on Ansys APDL simulation software. There are 3 types of dimension used in the experiment and 2 types of layers, which are 8 and 16 layers. For the layup sequence, it has 4 setup, which is unidirectional laminate, angle PLY 004 degree, 002 degree, and transverse laminate. Based on the setup, it can find out the deformation and stress contour and also maximum stress. Next is methodology, which contains 3 phases of work. As you can see, phase 1 contains literature review, gather information on previous study, and reviewing article for FRP composite. The next phase, which is the most crucial part, where simulation and modeling on Ansys that requires benchmarking, pre-processing, conversion analysis, processing, and post-processing. The final phase is where I gathered all the data from modeling and simulation and make a report writing. So these are the mechanical properties from coir and glass fiber. As you can see in the table, most of mechanical properties of glass is higher than coir, but the compression strength of coir is only data that is higher than glass. Benchmarking and method. Glass FRP is used as a benchmarking for this project. Their deformation were used to compare the mechanical properties of coir FRP after each testing. Ansys APDL will assist in doing the modeling and simulation on the composite. Dimensions are all using the American Society for Testing Material Standards. Pre-processing is when preference was set to be structural. Then the processing step can be started with a modeling of the model. The area of example is defined using 2 corners area of rectangle. Then the properties of the model are defined using structural of linear elastic orthotropy. The next step will be defining the lamination scheme of the sample using shell layup according to the fiber orientation. Processing is when the structure's displacement is set at a node in the center of the left side of the specimen, constrained in all degrees of freedom and the x direction for compression and open hole tension. The maximum stress is the load delivered during the test. If the failure index is 1, the deformation will be investigated in all 3 directions, X, Y, and Z. In the post-processing, the results of the modeling and simulation will be given. The graphics and motion of contour plot can be used to visualize data, deformation, and behavior. In Ansys, there are 2 types of contour plotting, that is nodal and element solutions. Next is preliminary and expected result. As you can see here, Table 1 and Table 2 shows the maximum compressive stress of glass epoxy and coir epoxy composites with various layup sequence. From the table, it is observed that the maximum compressive stress gradually decreases as the angle of fiber orientation increases. Glass epoxy with volume fraction of 49% possess the greatest compressive strength at 0 degree, followed by coir epoxy with a maximum value of 77.29 MPa and 75.41 MPa respectively. This suggests that as the fiber orientation shifted to a higher angle, the compression strength of the composite become more dependent on the strength of fiber matrix interface, thus showing the importance of the properties of matrix in use in the composite. Table 3 and 4 shows the maximum tensile stress of glass epoxy and coir epoxy composite with various layup sequence. From the table, it is observed that the maximum tensile stress gradually decreases as the angle of fiber orientation increases. The result indicates that specimen tested under tensile loading parallel to the 0 degree fiber orientation exhibit greater tensile strength as the specimen start failing with tensile rupture on the reinforcement fiber followed by debonding of the fiber matrix interface. Meanwhile, under transverse tensile loading at 90-degree fiber orientation, the specimen exhibit the lowest tensile strength as they fail with tensile rupture of the fiber matrix interface. This suggests that as the fiber orientation shifted to a higher angle, the tensile strength of the composite become more dependent on strength of the fiber matrix interface, thus showing the importance of the properties of matrix used in the composite. That's all from me. Thank you very much.